Hello and welcome on in. My name is Brian and I'm here for a Thursday afternoon mathematics stream. Coming in a little bit early today because I do have some meetings this afternoon. But last time we were together, it was a little while ago. I think it was like last Monday, last Tuesday, something like that. We started working on the Euclid math contest and I want to continue on that today, and there might be some ads incoming. And lucky me, my background computer is also restarting, so give me a second to get that all fired up. There we go. All right, so I think we had worked on, I think we had finished 3A and B, if I remember correctly. And I think we were all Gucci on those. So what I would like to do is I would like to continue working on number 3. So let's pick up 3C and maybe try to solve 4 today as well before I have to pop out for my afternoon meetings. And if you couldn't tell by the beautiful uniform that I have, I got called into work tonight. Well, not called, but I kind of volunteered. We have a comedy show happening at the brewery tonight, and I thought it would be fun to, one, not only go and listen to this comedy show, but two, I thought it would be nice just to kind of get out and see what's going on. See what's going on in the brewery tonight. This is a Euclid 2018 is what we're working on. Number 3C. All right, here we go. What does it say for us? A line with equation y equals mx plus 2 intersects the parabola with equation ax squared plus 5x minus 2 at the points 1, 5, and Q. So 1, 5 actually must pass through both, right? So 1, 5 must be not only on the line, but also on the parabola. Okay, I can kind of start to visualize this. I don't really know the value of m or the value of a, but without loss of generality, let's just kind of pretend we have a parabola and a line, so it must be intersecting it like this. Right, and you know, maybe P is over here, 1, 5, and Q is down here. Although we could, you know, P and Q could be swapped. This could be a parabola that opens down. The slope of my line could be negative instead of positive. So there's lots of other possibilities here. But this is kind of the general picture that I have in my head. So is it possible for us with only the point P, so if we only know point P is 1, 5, is it possible to use that to find M? I think so. So 1, 5 must be a part of this line. Message today. Hello, welcome on in. 65. Is it 65? 14 times 4. That's 40 and 16, right? 40 and 16 is 56. And 9, I believe, is 65. Nicely done. Nicely played. Yeah, sorry. I have to look over to look at the chat. I actually have to use Twitch right now because my other computer is rebooting. How have you been? How are you doing? It's feel like it's been a little, well, it's been a hot minute. How you doing? So yeah, I think we can sub 5 in for y, right? We're gonna leave m as it is, and we can sub in 1 for x. So 5 should be equal to m plus 2, so my math senses are telling me that m should be equal to 3. Is that true? I think that's true. I think I'm happy with that. So next up, is it possible to use only point P to find the value of A? Yeah, I think we can do that too, right? I think that should be relatively easy to do. And I don't think we're going to have to factor anything crazy like that, eh? I don't think so. All right, so we know that this point is on the parabola. So let's sub in 5 in for y and 1 in for x. So we're going to get a times 1 squared plus 5 times 1 minus 2. So what does that mean? 5 should be equal to a plus 5 minus 2, right? And I suppose we could probably just subtract 5 from both sides, right? Like those 5s are common, so we can just get rid of them. And so I guess that means that a should be equal to 2? Does that seem reasonable? I think that seems okay. Okay, so if we know that m is 3 and a is 2, is it possible to find the coordinates of q? In other words, we need to find both intersection points, both ordered pairs. This is kind of a nice question in the sense that if we can solve for number 3, we can probably verify that 1 and 2 are correct, I think. So we know that y is equal to 3x plus 2 is the equation of the line, and then y is equal to 2x squared plus 5x minus 2 is going to be our parabola. And I'm not going to use p this time. I think what we might do here is substitution. I might sub the line, or I guess we're just going to set the two y's equal to each other, right? So I have a y here. I know it's equal to 3x plus 2. I'm going to sub it in for this y down here. So 3x plus 2, let's set that equal to 2x squared plus 5x minus 2. And from here, we should be able to get two answers or two possible solutions for x, I believe. Hopefully one of them is 1. That would give us point P. And then whatever one is not 1 is going to be point Q. So let's see. Let's set this left side equal to 0. There's only the 2x squareds. We have 5x and we need to subtract 3. So that's going to give us 2x. And then we have negative 2 and we're going to have to subtract 2 more. So we're going to get negative 4. Now, it looks like we do have a common factor. Let's bring out that common factor of 2. And we need to factor this. So we should be able to factor this as 1 and 2, I think, right? Like x, how does this work? X minus, no. 1 and 1? Wait. Uh-oh. Uh-oh. Did we fuck up? Oh no, this should be okay. Plus 2 minus 1. Does that work? Plus 2 minus 1? I think that works. Crisis averted. Okay, so that gives us x is equal to 1, or x is equal to negative 2. And this is going to be point P, right? I believe. Right, 1, 5. And this negative 2 should give us a new point. So let's grab our y equals 3x plus 2. We'll take our line because it's a little bit easier to work with. And let's sub in negative 2. So 3, negative 2 plus 2. And that gives us what? Negative 6 plus 2. So y is equal to negative 4. So if our math is telling us everything appropriately, that means that the other intersection point must be negative 2 and negative 4. All right. I feel pretty good about that. Everything worked out well. We got x equals to 1 as one of our solutions, so that kind of verifies, I think, that we did 1 and 2 correctly. So I'm pretty happy with that. Okay, let's move into question 4. And let's see if I can clean up question 4 today. And probably be a little bit of a shorter stream today, and I'll be back tomorrow as well. This will be Euclid 2018, number 4A. This is a light bulb question, so we might be able to tidy this one up pretty quickly, but let's see. It didn't look like it was that easy when I read it. Is that Mr. Sensation Black popping in to say hello? It's time for another good idea, bad idea. Good idea, giving up cigarettes. Always a good idea. Bad idea, switching to a vape. If we had more viewers, I'd put a poll up and I'd see what the viewership would say. So I agree. I agree with the good idea. Giving up the cigarettes is probably a good idea. Now, with that said, if you think you need a vape in order to do it, then that's probably a reasonable thing to do. Move from cigarettes to a vape. But I have heard rumor that they do tend to be a little bit stronger, so some people have told me that the vape's a little bit harder to get off of. I don't know if that's true. I don't even know what that word is. Amylphenidate? Amylphenidate? What is that? Yeah, they make vapes with nicotine, right? You can just get nicotine. Amylphenidate. I don't even know what that was. Oh, yeah. I do know it is Ritalin. Yes, that is a word that I knew. They used to use Ritalin for ADHD, I think, right? They used to use it for ADHD medication, I want to say. I don't know if they still do. I don't know, I'm not a chemist, so I can't help out with this question. Okay, what does 4a telling us? The positive integers 34 and 80 have exactly 2 positive common divisors. Is that true? Let's check to see if that's true. So 80 can be broken down into 8 and 10, and 8 is composed of a bunch of 2's, and 10 has 2 and a 5 in it. 34, I believe, is 17 times 2. So yeah, well, 1 is going to be a common divisor of any pair of numbers. 1 is always the smallest common divisor. And yeah, the only other shared common divisor will be the number 2. That's it. Okay, so 1 and 2, that's it, that's all. I believe you, University of Waterloo. Mathematics faculty. Okay, your story checks out. How many positive integers between 1 and 30 have the property that n and 80 have exactly 2 positive common divisors? Okay, well, we probably are going to need... what did we say? This was 2 times 2 times 2, so that's our 8. And 80 is 8 times 10. Right, so here's our 8 and here's our 10. So we should be able to use this prime power, or this prime factorization, and kind of maybe scan through the numbers 1 to 30 and make this work. So let's just list the numbers 1 to 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I am pretty sure the number 1 is out because the number 1 is only going to share one common divisor with 80, and that is the number 1. Now, what else do we need to look for? We need to look for numbers that have, say, a factor of 10. Right? Because if our number between 1 and 30 is a multiple of 10, it's going to have more than 2 shared factors, right? So like 10 is going to share the factors 1, 2, and 5. Same with 20. 20 is going to share at least 1, 2, and 5, and maybe more. Same with 30. Okay, so let's get rid of all of our factors of 10. We can probably also get rid of the prime numbers from 1 to 30, because the prime numbers, I mean, other than 2 and 5, right? So like 2 and 5 are going to be the only ones that we are allowed to take because they are the prime divisors of 80. But all of our other prime numbers are not a part of 80, so they're only going to have one common divisor, and that's the number 1. It's the definition of these prime numbers. Okay, so let's get rid of all of these prime numbers. 17, 19's prime, right? 23, 25, 26, 27, 28, 29 is prime? Okay, I think those are all of our prime numbers. You know what worries me mathematically, he says. The current government advice is using 3 words for a password? Like 3 English words? Like just side by side? Okay, that would be 3 dictionary words. So did you go look up how many words are in the dictionary? What's bigger? 210,000 to the power of 3? Or 120 to the power of 12? That's a cool question. I can digress for a few minutes to think about this. Okay, so there's a couple things we do need to look up. The first thing I need to look up and verify is roughly how many English words we have. And let's just say, let's ask how many. Is that true? Like, is 210,000? The Oxford English Dictionary contains over 600,000 words. Wow. Oh, I see. So it includes about 171,000 that are in circulation and about 47,000 that are obsolete, they say. Okay. So even if we take your conservative estimate of maybe there's about 210,000, that's not unreasonable. It might be a little bit lower, but let's take a conservative estimate of 210,000. And if they want 3-word passwords, then you are correct. We would raise this to the power of 3 because we could choose each one of these words, and we could choose the same word if we wanted to. Do you know how this would change if it had to be different words? And I have a feeling we can try it on my calculator, but my calculator may not be powerful enough to do this. It might be able to do this one. Okay, that's not too bad. But that's a lot of zeros, isn't it? But I think Wolfram's going to be a little bit better for us. My calculator definitely will not be able to handle the second one. So 210,000 to the power of 3. There it is. What number is that? This is the thousands. All right, the millions, the billions, the trillions. What's after trillions? What's after trillions? Quadrillions? Quadrillions? So about 9.2 quadrillion possibilities? Okay. And if we choose random characters, yeah, I guess we'll have to look up how many different characters, including special characters, I suppose, too, right? And do capital letters, does that count? So how many English characters are there? So 26 letters. Unicode 7 has about 113,000 code points. That's crazy. Let's go at how many... Can we go ASCII? There it is, about 128. Yeah, about 128 is what we're looking for, right? All of the characters from 0 to 9, upper and lowercase English letters, and the special characters. So I would say it's about 128. We could even probably be a little bit conservative, and we'll just round this up to 130. Now, if we do want to have a fairly strong password, yeah, raising this to the power of 12 is not a bad idea, right? Picking 12 of these. I'm usually a little bit more conservative. I usually go with around like 8. So let's look at the difference between 130 to the 8 and 130 to the 12. I imagine it's going to make quite a big difference. Okay, what did we get? We got thousands, millions, billions, trillions. Wow, 130 to the 8 is 81.5 quadrillions. 81.5 quadrillion. Holy smokes, that's a big difference. That's like a 9 times size difference, isn't it? So asking people to just simply put 3 words back to back is about 9 times weaker than just picking random numbers and letters. That's wild. Yeah, that's crazy. And you're right. So this is when we're thinking about the process of this as kind of for encryption and decryption. Yeah, it's much harder to crack a random assignment of 8 characters from numbers, letters, and special characters. It's harder to do that than it is to grab 3 English words and put them back to back. And you're right. We would definitely be able to code break this one a little bit faster than we would this one. And in fact, sometimes too, when you give people the choice of selecting random words, they'll actually select words that they know and use a lot or think about, which also can probably affect this quite a bit, right? So if your code breaker happens to know a little bit about you and kind of what you do, they might be able to make educated guesses on what kind of words you're using. So it could possibly take this down a notch a little bit too. So it wouldn't be quite as strong. That's crazy. So the government actually said that? It's like the government's like, hey, you know what I really want you to do? I really want you to not secure your account so that we can hack into it. And that sounds like what the government is telling me. Crazy times. Back to our 80s example. Any multiple of 4 is out. Because any multiple of 4 is going to share 1, 2, and 4 as a common divisor. So 4 is out, 8 is out, 12 is out, 16, 20 is already out, 24, 28, those are all out. Now, any multiple of 8 needs to be out, but since all of our multiples of 4 are out, that should be fine. And then any multiple of 16 has to go out, but any multiple of 16 is already a multiple of 4, so we should be good to go. So anything that's left over, oh, there's some weird 3 things in here. Yeah, any power of 3 we have to get rid of too, don't we? So any power of 3, like 9, 27, those are going to be no bueno because they don't have a 2 or a 5 in them. So everything that's left over has to have it only 1, 2, or only 1, 5. 6 has 1, 2, and 1, 3. 14 has 1, 2, 1, 7. This has 1, 3, 1, 5. 18, what does this have? This has 9. This has a multiple of 2 in it, but not a 5. 21 is ooh, that's a tricky one. 21 is 3 times 7, so we have to get rid of that one. 22 is 2 and 11. 25 is 5. Ooh, 5 and 5 should be okay. And then 26 is 13 and 2. So those should all be okay. So I think it's 1, 2, 3, 4, 5, 6, 7, 8, 9. I think there are 9 numbers that would make this work. The weakest part of any system is the human element. Absolutely, yeah. As soon as they have some information about you, it starts to become a lot easier to crack the code. What a cool little thing, though. It's wild how powerful some of this simple stuff is, isn't it? It's kind of, it just blows my mind. Okay, let's see if we can finish up 4B today, and then I gotta get ready to head over to the college and then to work. Number 4B, this is 2018. So a function f is defined. F evaluated at 1 is 1. If n is an even positive integer, even and positive, then f evaluated at n is equal to f evaluated at n divided by 2? Huh? That's weird. If n is an odd positive integer bigger than 1, then f evaluated at n is f at n minus 1 plus 1. That's so weird. Okay. What a weird question. Okay, so let's look at f at 50. F at 50 is an even positive integer. Even positive. So I know that f at 50 should be equal to f at 50 divided by 2, which is f at 25. Okay, now that we have f at 25, we move into this next one. We now have an odd positive integer bigger than 1. So f at 25 is going to equal f at 24. We're going to go down by 1, and then we're going to add 1 to this. F at 24 plus 1. And it looks like we're just going to probably keep cycling through this way, right? So now we have an even positive integer, so we're going to divide this by 2. What is 24 divided by 2? Is that 12? 24 divided by 2. 12 is still even and positive, so now we're going to go down to 6. We're going to divide by 2. And we're going to, again, divide by 2 because 6 is even and positive. So we get down to f evaluated at 3. F at 3 should be equal to f at 2. We're going to subtract 1 and then add 1. But we still have this extra plus 1 kicking around. So it's really f at 2 plus 2. Okay, we're almost there. So this is f at 2 plus 2. This is an even positive integer, so we're going to divide this in half. That's going to give us, oh shit, get back, come back. Go away. Let's divide that in half. And we know that f evaluated at 1 is equal to 1. So I think our final answer here is 3. All right, so let's go back. Let's go back and check our answers, make sure we're looking good. So we worked on 3. Did we do 3C? Yeah, 3C. M is 3, A is 2, and our coordinate is -2, -4. Boom, that looks good to me. Okay, so when they solved A, they said 80 is 2 times 2 times 2 times 2 times 5. And so here are its positive divisors. Excellent. These divisors must be either 1 and 2 or 1 and 5, which was kind of what I was thinking. I just didn't say it explicitly. So n is a multiple of 5. Then the possible values of n come from the list here. Remove the multiples of 4, yep, since they would share too much. And the multiples of 10, which we did. That leaves us with this. And there are 9 integers left. Excellent. So that is nice. We got that one. Okay, we start with f at 50 and apply the rules. So apply the rules until we get down to f at 1, and then add up all of our ones that are left over, and we get f evaluated at 50 is equal to 3. Nice. Might be some ads incoming for you guys. I'll stick around for a few mementos as those ads finish up. And let's talk a little bit about what I'd like to do coming up this next week. So I do want to kind of continue working in the 2018 mathematics contest. I'll probably do that, a little bit of that tomorrow afternoon as well. And then we were working a little bit with Puzzle Andy in his Discord server. We were looking at kind of chocolates, and I was noticing that some of the patterns that I saw about this particular problem led to triangular numbers, which I thought was interesting. So I would like to kind of continue working on this particular question either tomorrow or next week as well. So that's kind of what's coming up on the dockets. And as always, if you guys do have some mathematics questions that you're curious about, we do have that Discord server. You can pop over there into the elements and you can ask your questions inside of the Discord server and get help either that day, or you can wait till the next stream, in which I usually try to solve those questions. All right, so I know it's a little bit of a short stream today, guys. I'm sorry, I'm just trying to get back into the swing of things. But I will try to be back tomorrow for you guys, and again next week. So, Sensation, good to see you. Mr. Jide, good to see you. Hope you are doing well where you're at. And I'm gonna sign out here, guys, and we'll see you tomorrow. Take care.